In this video, we'll look at some other possibilities for polar conics. In the last video, every polar conic in the last video had a directrix at y equals negative d, focus at 0, 0, whether it was a hyperbola, a parabola, or an ellipse. But there's other possibilities, namely 3 of them. For instance, what if the directrix is up here? So here I have y equals just positive 6, and the eccentricity of this ellipse is 2/3. Now, I'm going to do this one sort of from scratch, but then we'll get a formula in general for conics that have the directrix as a horizontal line above the axis here. I like to take a point in the first quadrant and call it r theta. So that's r. Here's theta. And I'm going to make this green line. That line's length is d. And this piece, which I'll make yellow, that piece there is r sine theta. So the relationship is that this line has to equal e times the distance of the directrix. That distance is d minus r sine theta. Why don't I make it blue? That's d, because d is all the way, the whole thing. So it's d minus r sine theta. In this case, I shouldn't say d here. I should say 6, because we actually know that. So 2/3, 6 minus r sine theta. Now, in general, and then I could rearrange this. In fact, I'm not even going to rearrange it. I'm going to say, what if in general it wasn't 2/3, but it was e, and instead of 6, it was d. And then I multiplied through ed minus er sine theta. And then I moved over the er sine theta. And then I factored out the r. And then I divide both sides by 1 plus e sine theta. I would end up with, let's put it up here, r equals ed over 1 plus e sine theta. Write that neater. So the only difference between this and the last case is that's a plus instead of a minus. So we have a new case here. This is the case where y equals d is the directrix. Here's our conic, and it's going to have a plus here. One way to remember that is that it's y equals positive d, has a plus there, where if it was y equals negative d, we have ed over 1 minus e sine theta. Okay, so now we have 2 cases. There's 2 more cases because we could have a vertical directrix. So let me clear this out. Okay, here's a question with a directrix at x equals negative 6, and the eccentricity is 2/3 again. No big deal. I can do it, call this r theta. Okay, this is r. I like to pick a point in the first quadrant. And I'm going to draw this green line. So we know that r is equal to 2/3, which is the eccentricity, times the distance to the directrix. I'll split that up though, like that. Now if this is theta, these lines are parallel, so there's also a theta here. That's going to be useful. And if this is r, this piece, which I'll make yellow, is r cosine theta instead, because it's sort of the adjacent side. And this blue line is going to be the 6, because that goes from 0, 0 down to there, so that's going to be 6. So specifically, this becomes 2/3 of 6 plus r cosine theta. In general, it becomes r equals e times d plus r cosine theta, which becomes ed plus er cosine theta, becomes r minus er cosine theta equals ed, becomes r 1 minus e cosine theta equals ed, becomes ed over 1 minus e cosine theta. And that's our third case. So, I'll write it again, ed over 1 minus e cosine theta. So, if it's x equals -6, if it's x equals, there's going to be a cosine here instead of a sine, and if it's -6, it's going to be minus there. And the only, well, there could be diagonal directrixes, but not for me. There isn't going to be x equals +6, eccentricity equals 2/3. Again, I like to go to I make my r theta there. So that's r. That has to equal e times whatever this line is. So r equals 2/3 times whatever that green line is. Well, the green line, see this yellow line? That's 6. And this blue line, here's theta. Theta is also over here. And if this red line is r, and this blue line is going to be r cosine theta again. So this one is going to be 6 minus r cosine theta. In general, it's r equals e times d minus r cosine theta, becomes r equals ed minus er cosine theta, becomes r plus er cosine theta equals ed, becomes r times 1 plus e cosine theta equals ed, becomes r equals ed over 1 plus e cosine theta. So if it's vertical directrix, it's going to be cosine. If it's x equals a positive number, is a directrix, it's going to have a plus there. So those are the 4 cases. Now we'll finish up by, for each of the 4 cases, I'll do a question and show you how you could graph it. So imagine the question said r equals 20 over 5 plus 4 sine theta. First thing I would do is divide by 5, so I get 1 plus 4/5 sine theta. Now I know that its eccentricity is 4/5, because that's e. This thing's ed, so 4/5 times d equals 4, so d equals 5. There's a sign here, so it's a horizontal directrix. There's a plus here, so the directrix is at y equals plus 5. Also, we know it's an ellipse, because the eccentricity is less than 1. And then, knowing all that stuff, it's going to be useful to do 4 values, 90, 180, 270. I could probably put them into this guy. Sine of 0 is 0, 20 over 5 is 4. Sine of 90 is 1. 20 over 9 is about, 20 over 9 is 2 point something. Sine of 180 is also 0, so that's 4 again. Sine of 270 is -1. 20 over 5 minus 4 is just 20. So when I graph these, I get 0, 4, 90, around 2, 184, and 270, 20 is way over here. And I make my graph like that. I'll just do one other. There's 4 cases, but I hope you get the idea. Here's one, r equals 30 over, let's see for a second. Let me do this one. This is, how about 20 over 4 minus 5 cosine theta. Okay, I don't like that 4. I wish it was a 1, so I'll divide everything through by 4. At this point, I know E equals 5 over 4, so it's a hyperbola. I also know because it's cosine, I have a vertical directrix, and because it's negative, the directrix is going to be over here somewhere. What exactly? Well, ED equals 5, 5 over 4 times D equals 5, so D equals 4, and that's why, oops, I went on the wrong side. Oh, this is a minus, so it's X equals -4. There's my directrix. My focus is always at 0, 0. I know it's a hyperbola, so when I make my chart of the 4 basic values, once you know all this information, we don't really need much more than 4 points. Cosine of 0 is 1. 20 over 4 minus 5 is -20. Interesting. So my first point is all the way over here. 90, cosine of 90 is 0. 20 over 4 is 5, so 95. Cosine of 270, I'll do this one, is also 0, so that's 5. And cosine of 180, cosine of 180 is -1, so it's 20 over 4 minus -5, which is 20 over 9, so that's 20 over 9. So 180, interesting. So that point, so then if I know it's a hyperbola, it must go like that, and this must be the vertex of the other branch. Okay, now you can do all 4 types. Why don't we summarize the 4 types? This one is r equals ED over 1 minus E sine theta. This type is r equals ED over 1 plus E sine theta. These aren't quadrants, these are just the 4 possibilities. This type is r equals ED over 1 minus E cosine theta. And this type is r equals ED over 1 plus E cosine theta. If it's a vertical directrix, it's cosine. If it's a horizontal directrix, it's sine. If it's y equals something negative, it's going to be negative there. If it's y equals positive something, it's there. If this is above, if it's x equals negative, this is a minus. If it's x equals positive, it's positive. There you go.